Welcome. Let's solve Leetcode 2381, shifting letters 2. Let's make this bigger so we can read this easier. Okay, shifting letters 2. You are given a string S of lowercase English letters and a two-dimensional integer array shifts, where shifts I equals start, end, and direction. For every I, shift the characters in S from the index start to the index end, inclusive, forward if direction is 1, or shift the characters backward if direction is 0. Shifting a character forward means replacing it with the next letter in the alphabet, wrapping around so that Z becomes A. Similarly, shifting a character backwards means replacing it with the previous letter in the alphabet, wrapping around so that A becomes Z. Return the final string after all such shifts to S are applied. And let's just go over this first example here. So here we have ABC and these three shifts. The first shift indicates that from index 0 to index 1, we move backward because of the 0. So now S becomes ZAC. The next shift tells us to, from index 1 to index 2, we move forward. So now the string becomes, so we left off here, and now the string becomes ZBD. Lastly, our last shift indicates from index 0 to index 2, we move forward. So the string becomes ACE. And that's all there is to it. I think the problem is a little bit straightforward, and I like that. So let's go over how we'll approach this problem. Okay, so I'm going to use the same example here, and I think we can just get started. So what we're going to use is, or leverage, is something called a difference array. At least that's typically what it's called. I'm not so enthusiastic about that name. However, that seems to be the most common, so we'll just go with that. So currently what we have is, suppose we have our shifts look something like this here. Shifts equals maybe 0, 2, 1, and we have another shift that says 0, 2, 0. So that would mean that starting at index 0 to index 2, so we move forward. So that would take let me see, length. If suppose the length of our string is n, so suppose length of string is n. So for looking at every one of these shifts here, the naive time complexity would be n times, now m would be, in this case we can say length of shifts. So this is what we would have. So if we loop through our shifts, we say, okay, we would have to, this index could be 0 and this can be the end of the string. So we can have to, for every single shift, we would have to apply a shift to every one of the characters of the string. And now notice in this case, the start index and the index and the ending index are the exact same for the shifts here. But notice the only difference is moving forward and backward. So what we're trying to do is we'll try to reduce our shifts by calculating net shifts, so that we only apply shifts once for string S. So we're trying to reduce this n times n to, now I think we can do something like n plus m. So we still need to figure out the net shifts. That's still going to take m time. But if we only apply the shifts once, that would just be the length of the string. So the goal is to reduce the n times n complexity to n plus m, which would give us a great boost. Okay, so let's figure out how to do that. We can do what we can do is we can again, as I mentioned earlier, keep track of our number of shifts. So I'm gonna call this maybe like I'm just gonna call it diff for like and this will represent the number of shifts, the net number of shifts, the net number of shifts. Okay, so let's figure out how to do that. So what we'll do is we'll say, I think we can just implement that now, in fact. So what we'll say is something like this. We'll call this maybe, first we need to know how long this should be. So what we'll have is for every index, we'll need to know how many shifts we need to apply for every index. So let's do that. So we'll say something like n equals the length of s, and our difference array will be 0 times n. Okay. And well, so we want to calculate this difference array. So okay, so let's figure out how to do that. So what I'm going to do is I'm going to say for I, j, k in shifts. And remember, each of these represents the start, the end, and this is, remember, the end is inclusive, and k is the direction. So I'll say something like, if k equals 1, then we add 1 to our difference array. So we say, okay, difference of the start, and we'll say plus 1, plus equals 1. And the other way around says, otherwise it's going to be 0. Those are the only options. So we say difference of I minus equals 1. Okay, so this so far is just a naive implementation of our difference array, how we're going to store them. Because notice we haven't included the ending index. So we're going to build that in a moment. I just wanted to get us started. Okay, so let's look at this. Let's look at it. So let's print it just to get a good look at it. And in order not to get an error, we'll just return the original string. And let's run it. I've created another example here 3, and this is the query that I've decided to run with, which is the one that we went similar to this one here, which means starting at index 0 all the way to the end, we're going to move forward 1. And this is our what the difference array would look like. So notice how we have our start, our shift, and here at index 0, but nothing else indicated for the other indices. So what we'll do is we'll kind of roll over, we'll keep a running total of our shifts. So let's figure out how to do that right now. So what we'll do is we'll do something like this here. Let's maybe make this smaller. So we'll say, okay. So then for I in range n. One thing we want to do is, as we progress through our index, for every index n, we want to keep track of our result. So we'll say result equals, and we'll set this equal to maybe just an empty string. It really doesn't matter. Times n. And we'll keep track, as I mentioned, we'll keep track of like a running total of our shifts. So we'll just say something like, we'll just call it that, num of shifts. And initially we'll start it off at 0. Okay, so we'll use that here. So we'll say, okay, the number of shifts will equal the previous number of shifts plus our difference array, whatever, which stores the number of shifts at every index. Now potentially this can get too big, so we'll need to modify it, mod it 26. I'm actually just going to print this here. So that, what does it look like? Print number of shifts. And we'll just say maybe I here too. So let's run that. So at index 0, we shift 1. At index 1, we shift 1. So this is kind of what we want here. That's exactly what we want. So, okay, so that's good. So now let's figure out how to apply that to our answer. Okay, so let's do that. So what we'll do is we'll say at result at index I, we'll set it equal to some character, some char. So now how to figure out what this char is. So we'll start with our string. So we'll need to convert it to an ASCII value, ASCII numeric value. So we'll say ordinal of S of I. That's the current letter. Then we'll say, okay, we'll want to reduce it by 97 to get it into a range between 0 and 26. And we'll say, okay, plus the number of shifts. Okay, so in this case, our first letter would be A, which is 97, minus 97, plus our number of shifts, which is 1 currently. So this would be 1. Potentially, though, you can imagine, though, that it can grow outside of, like, for example, what if our number of shifts was 1,000? So what we'll need to do is we'll need to mod it 26, the number of letters in the English alphabet. But remember, though, this is only a value between 0 and 26. So then we'll need to shift it into the range from 97 to 122. So we'll use this here. And this is pretty standard for interacting with ordinals and shifting. Okay, so this is a numeric value. This is a numeric value. But we'll want to convert that to its actual letter. So what we'll use here is we'll use this, the char method from Python, and that'll be the letter. And we can just return this here. So remember, this result I is a list of empty strings, or at this point it'll be just a list of strings, and we'll just join it. Okay, so let's run it and let's see what this looks like. And we're currently working on example 3 here. So remember, the string is ABC, and we're shifting every letter once from index 0 to index 2. That's basically the entire string, and we're moving it forward. So we have BCD. Okay, that's great. Okay, so that looks pretty good. So we're progressing really good. So now the question becomes, now in our example here, let me take this off for a moment. In our example here, we shifted every letter from 0 to 2. But now suppose we just want to shift the letters from 0 to 1. So let's change that. Let's change our test case and see how that messes up our answer or our approach. So let's change this from 0 to 1. Sorry, let's go here to the test case. And change this from 0 to 1. And let's see how that affects our test case. Let's go back over here. Did I remove our print statements? Yeah, let's print this here maybe. Let's print our difference array. So print diff. Okay, and let's print maybe the number of shifts. So print num shifts. Okay, let's try that out. Okay, great. So what we have here is, so this is our difference array. So notice it only really accounts for the starting index, so 1, 0, 0. And notice, as before, the number of shifts is 1 all the way through. So we changed all of the letters from, remember it was ABC, we moved all the letters forward, so BCD. This is our, as the output as similar to before. But remember though, we only want to shift the letters from 0 to 1 and leave the other letters unchanged. So we have a problem here. So we'll need to modify our difference array. So how do we do that? Okay, that's a great question. So let's do that now. So let's go back. It's going to be here. It's going to be back here. So what do we want to do? So remember, if you recall, the difference array currently looks like this: 1, 0, 0. When we have a shift provided like this, our difference array looks like this. In order to get around this issue, we'll need to indicate where we want to stop. So how do we do that? So remember how this is, the endpoint is inclusive. So what we'll want to do is at the end index plus 1, we will what's the word? I don't want to say subtract 1. I want to say perform the inverse direction. So why did I say that? So in this case, see how this is 1? That means we're moving forward. So from 0 to 1, this is okay. Remember from our example, that was perfectly fine. But afterwards, we want to not do that. So remember, currently our number of shifts, as we progress through our when we used our difference array to calculate the result, it was 1 all the way through, right? It was 1, then it was 1 for the next index and 1 for the next index. What we'll want to do is we'll want to, what it should be is something like this: 1, 1, 0, and then we'll want to change this to, and we want to go back to what it was originally. So hopefully that makes sense. So what we'll do is we'll say at end index plus 1, we will perform the inverse direction. So what does that look like? So here, so when we're at our, we need to look at our index. So the end index is j, but we want to look at the index afterwards. And we'll say, okay, minus equals 1. Now this is for the forward direction. We want to do subtract equals 1. Now we'll have a little bit of a problem here, right? Because what if j plus 1 goes beyond the length of our string? So we'll need to perform a check first. So we'll say, okay, if j plus 1 is less than n, then we'll do this. So this is only concerned with the forward direction. Now we need to do something similar for the backwards directions. Let's basically copy that and modify it. So if j plus 1 is less than n, then we'll want to add 1 here. Okay, so then let's run this again and let's see how this how our difference array is affected. So let's look at it. So let's run this again. Okay, so let's look at this and let's see what's going on here. So notice how our difference array is a little bit different now. So 1, 0, now it's -1. So at index 0, let's maybe look at this here. So we shifted 1. And notice though how our num shifts, sorry to do that here. Notice here how our number of shifts is carried over for every index. This is an equal sign here, right? This is an equal sign. So initially it starts off at 0, number of shifts is 0, we set it to 0, and then we added 1 to it. And then at the next index, number of shifts is 0. Sorry, number of shifts is now 1 because it stays from the previous value. It stays the same as the previous value from the previous iteration. But here though, notice how difference I here is 0. So we don't change the number of shifts. It stays the same. Notice how these two are the same. However, though, notice here though, we have a -1 here. So this basically undoes the number of shifts, at least by 1. It undoes it by 1. And it sends it back to 0. So the number of shifts, is, yeah, so the number of shifts is 1, 1, but then when this number of shifts meets this -1, 1 minus 1 is 0, so we get that. And in that case, that allows us to arrive at our correct answer. And that's basically it. Notice how all of our test cases passed. Let's just walk through it again real quick. A lot of the, I guess, calculation is performed here. If we're moving forward, we tell our difference array, okay, we're going to shift forward here. And then we tell it where to end, where to stop moving forward. And we do that by using an inverse of what the direction is. And then we do the exact same opposite for the backward direction. And that's basically it. Let's maybe submit it. Let me take off these comments because they might cause the submission to fail. Okay, let's submit it. Okay, looks pretty good. Let me take off all these other comments. I don't think we need them. I think that's about it. I'm trying to think if there's another thing I can do here, but yeah, it looks fine. Yeah, I think this is okay. In any case, I'll just submit it again without those comments at the beginning. If you found this video helpful or instructional or beneficial in any way, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.